One thing my students really struggled with when I taught Math 1030 2 years ago were problems involving the testing for a certain disease and the probability that the testing is accurate. So this seems appropriate this year for sure. And one way to do problems like this is by using a two-way table. So I've got this problem written down that I got out of the textbook. And then you can see the table that I created based on the information. So if you'd like, we can kind of just go through where these numbers came from one at a time. Trying to think the best way to maybe show or not show what we've done, but I think I'll just go for it and just explain what's here. Okay, so a two-way table has two different things that are happening that are not mutually exclusive. So in other words, they can have an overlap, and we can show that with like a Venn diagram, or in this case, a two-way table. So our two-way table shows different things. It shows whether a person is infected or not infected with the disease, and whether they test positive or test negative for the disease. So in both cases, we're assuming that our total is 100% of the population. Everyone is either infected or not infected, and then everyone tests, and that they either have a positive test or they have a negative test, right? So this 100% down here in this corner represents 100% of our population. Okay, a certain disease has an incidence rate of 2%. That means that 2% of the population actually has it. Okay, maybe this is not as much a communicable disease as something that's genetic or just like shows up in someone. Okay, so 2% incidence rate. So 2% of the 100% population will have this disease. That means that 98% of our population does not have the disease. So where did I get the 100? Well, 100% of the population, everybody. Where did I get the 2%? It tells me right here. A certain disease has an incident rate of 2%. How did I get the 98%? Well, I simply took 100 and I subtracted 98 and I got 2%. Or subtracted 2% and I got 98%. So that these two numbers, 2 plus 98, add up to our 100%. Okay, so that last column of totals is what happened first. Next, we have more information in our paragraph. If the false negative rate is 10% and the false positive rate is 1%, compute the probability that a person who tests positive actually has the disease. Okay, let's focus on one at a time. So false negative rate. So that would mean the term false negative means that a person tests for the disease and tests negative, but they actually do have the disease. So remember, if 2% of our population has the disease, then those that have the disease that test negative would be 10% of that. So to find a percent of something, we change it to a decimal. So 0.10 times 2% of the population means that it's going to be 0.2% of the population that would test negative but actually have it. Okay, now that we have that number, we can find this number by subtracting these two numbers. So we can go 2%, subtract 0.2%, and we can get 1.8% that way. So that these two numbers, 1.8% and 0.2%, add up to our 2% total. Now, I did show my work over here doing this a different way using this column instead of this row, but that's interesting because I got the same answer either way. Okay, the next thing we know is that a false positive rate is 1%. So that would be right here, where someone is not infected, but they test positive. That's called a false positive. So that would be a 1% or 0.01 times the 98% of the population that does not have the disease. So 0.01 times 98% is 0.98% of the total population that don't have the disease but have a positive result. So now they think they have the disease, but they don't really. Okay. So now we have that number. So this number we just figured from 100% of the population. This was given to us. We subtracted to get this number. Then we used the given percent with this number multiplied to find the percent of the population with a false negative. And then we used this number with a 1% multiplied together to find the population of those that are not infected but get a positive test result. Okay, now in order to get these other numbers, I already talked about this one, but to get the other numbers, we just have to make sure every row and column adds up. So like 2 plus 98 is 100, right? So we have this number right here, so we took 2 minus this number to get this number. And then we know what this number is, and we just found this number. So we can take, you can see my work right here, where I took 98% of the population is not infected, subtracted by the number that are not infected but test positive, and that gives us the number that are not infected and test negative. So that's 97.02% of the population that test negative and are not infected. So 97% chance you get tested for this disease and it's negative. So you get that accurate result, right? For a total of 98% of the population that does not have that disease. So these two numbers add up to this number. And these two numbers add up to this number. And now these two numbers have to add up to this one. So we have 0.2% and we have 97.02% that we got from taking this number subtracts that one. So then these two numbers add up to 97.22%. So then to find this number, we take our 100% of our population, subtract out the percent of the population that tests negative, and that gives us 2.78% that test positive. So that this 2.78, here, can I highlight these? Probably, let me find a highlighter. So that this 2.78 plus this 97.22 add up to 100, and this 0.98 plus this 97.02 add up to 98, and this 1.8 and this 0.2 add up to 2, and then everything adds up this direction as well. 1.8 plus 0.98 adds up to 2.78, 0.2 plus 97.02 adds up to 97.22, and 2 plus 98 is 100. So I don't know if that makes sense. Okay, now that we have our chart done, and I took a lot of time explaining that, but I wanted to make sure we understood where all these numbers come from. Now we can go ahead and find our probability. So we're trying to find the probability that someone is infected given that they tested positive. So that means we're finding the probability, let me change my pen here, that we're finding the probability of 1.8 of the population that is positive and tests positive. So they are infected and the test comes back saying that they're infected. So that's 1.8% of the population. And we're going to divide that by the total percent of the population that tested positive. So we have a 2.78% of the population that tests positive. 97.22% of them test negative, and all of them test, right? So we have 1.8% that test positive that are actually infected, divided by the 2.78% that test positive. So this is the total that test positive. This is the percent that actually have the disease. So now we use those numbers to find our probability. So using a calculator, I'm going to go on 1.8 divided by 2.78, and I get 0.64748, which is a 0.65 probability, or 0.647, or you could say a 65% chance. So there's a 65% chance that you could have the disease and test positive for it.